make sure you're in the polar mode. And when you're in the polar mode, you just type in your equation. So in this case, it was 1 plus 2 cosine theta. And then what you're going to want to do is, I'm in degrees. If you looked at my mode, I'll go back to my mode. I'm in degrees, which means when I go to my table, or my window, pardon me, you'll notice that they have these things. What is this set up for right here?
Degrees, min, max.
Nope. What is 6.28? 2 pi. Because 1 pi is 3.14.
Okay.
So 2 pi is 6.28. If I want to go once around a circle, and I'm in degrees, I would start at how many degrees? 0. But then I would go up to 360. And I'm probably going to go up by, oh, I don't know. Let's try 10 degrees at a time. And let's graph it and see what happens. Remember, we already know what this looks like. Oh, is it there?
Yeah.
Yeah. So that's one way you can do it on your calculator. Questions? You can also do it in radians. If you're going to go in radians, I'm going to tell you that what I would do instead of what you see here is, if you're in radians, I would probably go from 0 to 2 pi. I'd go up by pi over 24. I don't know why this works really well, but I just know it does. So this is called your step, where this was your min and your max. And then to find out your x and y values, all you have to do is look at the biggest values in your table. So like in this table down below, we see the biggest value is 3. So probably what I would do is, for my ranges in x and y, what I would do is I'd go from -3 to 3, and that would cover me in my table. If you were using radians, we talked about what we'd use, but we just got done with degrees. So in degrees, we went from 0 to 360. This was your max and min, so min and max. We were going up by 10 degrees. You could probably even go up by 1. It would just draw it slower. So this is your step that you're going up by. And then your window, your x and your y's wouldn't change. You'd go from -3 to 3 still, because that's talking about what you see in your window, like how far out on this graph do you want to see it. Thus begins the super secret notes. For 10.7. Number 1. If you see r equals a number, like, for example, r equals 3. This is a circle with a radius of 3. So I see my picture. Here it is. I have my rings. 1, 2, 3, 4, whatever. And I know that this circle is this. Nope, that's not what I meant. I just put it at 4 and I said 3. Sorry. So here's my circle. We already talked about that, actually. So r equals any number, circle, out that many rings, done. Second, if you ever see something like theta equals a number, for example, like theta equals pi over 4, this is a line every time. So I see my rings. Again, doesn't really matter how many rings there are in this case, and you have your different lines that are coming through. And we know that this is pi over 2 over here, this is 0, this is pi over 4, pi over 6, pi over 3, then the line that you're talking about is the one that goes through pi over 4. Okay, we already talked about that one. So these two super secret notes you already know. And I want you to notice something about these 4 pictures. First picture. Equation. Second picture. Just watch, I'll give you a chance to draw. So anytime you see r equals sine of theta, you're going to have a circle. Also, you know that when it's sine, these circles are vertical circles, meaning it'll either be above the x-axis or below the x-axis. If it's positive, it's above. If it's negative, it's below. The number in front of the trig function is the diameter of the circle. I would like to point out something really interesting. This is in polar. Check this out. If I know that that circle goes up to 2, that means that the center of the circle is at
0, 1.
0, 1. Which means if I want to write this in rectangular coordinates, or what we call function notation, I can do this, in case you don't remember.
X minus 0.
The 1 on the right-hand side is the radius of the circle. Because if the diameter was 2, the radius is 1. If I were to do the same thing for the second circle, this circle has a center at 0, negative 1, which means its equation would be x minus 0 squared plus y plus 1 squared equals 1. Still same topic, another graph. How about this one? Would anybody like to hazard a guess to the equation of that graph?
It's cosine.
It is cosine, so you would write down r equals
Positive 4.
positive 4 cosine theta. And if I drew this graph, the equation of that graph would be r equals negative 5 cosine theta. So left and right graphs are cosine, which makes sense because cosine was like our x that went left and right. And sine graphs are like our y, so they're up and down circles. And the number in front is always the diameter. If I were going to be locating the centers then, on this particular graph, this center would be at negative 2.5, comma 0. And this center would be at 2, comma 0. So that if I wanted to write the equations of those circles in what we call function notation, I could do x minus 2 squared plus y minus 0 squared equals 4, because 2 squared is 4, and the radius was 2. And in the next one, if I want to write the equation of that circle, I could do x plus 2.5 squared plus y minus 0 squared equals 6 1/4. Because 25 squared is 625, but there are 2 decimals, 2.5 times 2.5. Check it out on your calculator. It's 2.5 squared.
Right.
So remember that when you're doing the math, it's always equal to the radius squared, which is the same in this case as 2.5 squared. And the 2.5 came from right there.
But does that tell us anything, or is that just?
Yes, it tells you how far from the center you went out to the edge of the circle.
Oh.
These next graphs are called roses. I don't make up these names, they just tell me what they are. And I'm going to do again a series of 4 graphs. I'm going to write down the equations. This does work for sine or cosine. I'm only going to focus on one. It doesn't matter which one it is. So sine of theta or cosine of theta. I'm just going to use sine because I've already drawn these graphs before. Whether you have sine or cosine, we'll just change the orientation of these roses. Okay, but the look and what it actually does and the pattern is the same. And that's what I want to focus on. So let's look at the first one. This first rose looks like the following. It is going to be R equals 2 times the sine of 3 theta. And when I draw it, it looks like the following. I want you to just watch for a second. Don't worry about drawing. I'll give you time. The second one that I'm going to draw looks like this. This one is going to be R equals 2 times the sine of 5 theta. And I don't have room to draw the parentheses, but there'd normally be a parentheses around the angle measurement, which is called 5 theta. And what I want you to notice, after I get done with all 4 of these graphs, is any patterns you might see. I'm moving on to the next ones, and then I'll come back, and then I'll have you think about them. So take a look at them. 2 sine 3 theta, and 2 sine 5 theta. Next 2. And I'll come back. Don't worry, I'll give you a chance to draw them all.